Isaac Newton, the scientist who gave the laws of motion and law of gravitation. Newton has given 3 laws to describe the motion of bodies. These laws are known as Newton's law of motion. The Newton's law of motion gives a precise definition of force and establishes a relationship between the force applied on a body and the state of motion acquired by it. Some of the bodies around us are at rest. That is, they are stationary, whereas some others are in motion. Newton's first law describes the behavior of such bodies which are in a state of rest or uniform motion in a straight line. So today we are going to study about Newton's first law of motion. It states that a body at rest will remain at rest, and a body in motion will continue to be in motion in a straight line, of course with the uniform speed, unless it is compelled by an external force to change its state of rest or uniform motion. Here, by external force, I mean force from outside the body. Okay. And now I will divide this Newton's first law of motion in 2 parts. A body at rest will remain at rest. This is the first part. A body in motion will continue in motion. This is the second part. Okay. We'll study these 2 parts of the Newton's first law of motion and we'll take many examples. For example, I'm going to explain you the first part. For example, this book is lying on the table. It is at rest. The book will not move by itself. That is, it cannot change its position of rest by itself. It can change its state of rest only when compelled by the force of my hands. That is, when I lift the book from the table, then this position of rest of the book will be changed by the external force of my hands, and it is the position of it. This book is changed. So in this way we can, this is very simple experiment, and to understand more clearly I'll tell you that Newton first law recognizes that every body has tendency to remain at rest, that is, to remain in a stationary position, or if moving, to continue moving in a straight line is called, and this tendency of a body is called inertia. Inertia, a tendency of a body due to which it resists a change in its state of rest or uniform motion. So, greater the inertia of the body, greater will be the force required to bring the change in its state of rest or of uniform motion. In fact, mass is the measure of inertia of a body. Mass is a measure of inertia of a body. This means heavier objects have more inertia than the lighter object. For example, there is a stone and a football of same size lying on the floor or on the ground, and if you are asked to kick them, then whom you will prefer to kick? I hope I'm assured that you will not prefer to kick stone. You will prefer to kick football, because football is lighter in comparison to the stone, so it has less inertia. Its mass is more, so it has more inertia. So likewise, small car means a toy car has small mass, so it will have small inertia. A real car, I will say, real car will have more mass and large inertia. So it is difficult to move this real car by pushing it. So that means you have come to know that to overcome the inertia and to make a body move, we must apply an external force. Okay, so we will we can illustrate the Newton's first law of motion, or a property of inertia of a body, with a simple experiment described here. We take a glass tumbler and place a thick square thick card on its mouth as shown here, and a coin is then placed above the card in the middle. Now let us flick the card hard with our fingers, like this. On flicking, the card moves away, but the coin drops into the glass tumbler. Why? See, look. Initially, both the card and the coin are in the state of rest. Now, when a card is hit with our fingers, the force acts on the card and changes the state of rest of that card to the state of motion. Due to this, the card we have to hit hard. The card moves away from the mouth of the glass tumbler, and the force of our flick, however, does not act on the coin. So the coin continues to be in the state of rest due to inertia. And when the card moves away, the coin falls into the glass tumbler because it prefers to maintain its state of rest. Okay. Now we will come to the second part of the law. First law of motion. Second part of the first law of motion states that a body in motion will continue to be in motion in a straight line unless it is compelled by the external force to change its state of motion. So we'll take example of a hanging carpet. Okay, so when we'll take the example from our everyday life. When a hanging carpet is beaten with a stick, what happens? The dust particles, they start coming out. This is because the force of the stick makes the carpet move to and fro slightly, but the dust particles tend to remain at rest due to their inertia and separate from the carpet. Similarly, when a tree is shaken vigorously, its fruits and leaves fall down. Because when the tree is shaken, it moves to and fro slightly, but its fruits and leaves tend to remain at rest due to inertia and hence detach from the tree and fell down. So in this way, we have seen both the parts of Newton's first law, and Newton's first law of motion gives us the definition of the force. It says that a force is something which changes or tends to change the state of rest or uniform motion of a body. And force, please remember that force is a vector quantity. So let's finish it off here and wait for the next session.